So for section 9.4, this one is really, really long. I'm going to break this up just like Hawks does. Hawks breaks this up into three pieces. 9.4a, which is addition, subtraction of radical expressions. 9.4b is multiplication of radical expressions. And 9.4c is division and rationalizing radical expressions. So this first video is going to be for 9.4a, the addition and subtraction of these radical expressions. So just like 2x squared, 3x squared, negative 8x squared are like terms because they have the same variable part. The terms 2 square root of x, 3 square root of x, and negative 8 square root of x are also like terms. They also have the same variable part. Now remember, to combine like terms, you keep that variable part, in this case it's that radical component there, and you combine the coefficients by addition or subtraction. Okay. So let's look at combining some like terms here. So if we have 2 square root of x plus 3 square root of x minus 8 square root of x. Now, instead of saying square root every single time, you may hear me abbreviate this as by just saying 2 root x plus 3 root x minus 8 root x. That means the same thing. So if I just combine those coefficients, noticing that these root x's are all alike, makes them like terms, that 2 plus 3 minus 8 gives me negative 3. So right there is where that negative 3 comes from in my final answer. So let me color code this for you. So this is where that negative 3 comes in. The root x is just that variable part. Just like if this were 2x plus 3x minus 8x, I would get negative 3x. Okay. Next up, if we have 2 root x plus 3 root y minus 8 root z. None of these are like terms. This may look very similar to the previous example, but notice one is a root x, one is a root y, one's a root z. So these are not like terms. They don't have the same variable part, so they can't be combined. So if this were an example in Hawks, what would the answer be? The same thing. Nothing can be combined. All right, so if I were going to simplify this next one, that root 36y and root 49y, those aren't like terms, but I can simplify this. So let's simplify the radicands first. So remember, the radicand is the thing under the radical. So for instance, that 36y, remember I can use, where is it? This property right here, number 5. I can use that exponent rule number 5 to split this up into two radicals. So that negative's along for the ride. That splits up into root 36 times root y. That's because that's multiplication, because of that smushing right there. Same thing over here. 6 is just brought down. The 49 times y can be split up. You can do this with roots with multiplication and division, not with addition. If this were 49 plus y, we can't split those apart. So now, check it out. The square root of 36 simplifies to just be 6. The square root of 49, that simplifies to just be 7. Everything else is just carried down, right? So the negative, that's 6 root y, plus 6 square root of 49, 7 root y. Now simplifying this just a skosh further here, we get this negative 6 root y plus 42 root y. Now these are like terms, right? So these are now like terms. I can combine those. Negative 6 plus 42 is going to give me 36. And then that root y is brought along because it's what makes those like terms. So I know there was a lot that happened in there. It was a lot of chapter 9 kind of thrown at you at one time. We had that exponent rule that allowed us to break those apart. right? And then we have those like terms that we were able to combine. But this one was tricky because it looked like it did not have any like terms in the beginning, but you had to simplify the stuff under the radical first, and then boom, like terms just kind of showed up. Okay. Next up here, after I wiggle this paper around and stuff for a bit. All right, looking at these three terms, only these two are the like terms. You may be like, oh, well, they're all 2's. Ah, but wait, that one's a cube root, square root. So only these 2 cube roots are the like terms. So combining those, that'll combine the 4 plus 7 and give me 11 cube root 2. This is just along for the ride. These are not like terms, so they can't be combined. So that's the best you can do with it. Okay. So we're looking to simplify this expression. It looks like they're not like terms because one's a root 9x and one's a root x. But let's simplify that radicand first. So let's simplify. Oops. So let's simplify that first. Just like we did last time, where we can split that stuff apart. And then just like last time, in doing so, that square root of 9 simplifies nicely to just be 3. Now we can multiply that 4 times 3 and get 12 root x minus 7 root x. Now these are like terms. I can subtract that 12 minus 7 and get 5. So 12 minus 7 is going to give me 5, and the root x is brought along because it's what makes these like terms. All right, continuing on with this addition and subtraction. So 4 times the square root of 7x minus 7 square root of x. Now I did this one on purpose like this because I could see where you might get those confused, where you might look at that and say, oh wait, those are like terms. No, they're not. One has 7x under the radical, and the other one, the 7's outside and only the x is under. So to start with, these are not like terms. However, let's simplify them. So let's take this square root of 7x and let's split that up into 2 radicals. So I'm going to split this apart. So that square root 7x splits up into square root 7 square root x. Now in doing so, you remember just like before in the previous examples, if I had like 4 times 3, I could just multiply it and get 12. Well, I'm going to do the same thing. That 4 root 7 and then minus 7. These are now like terms. So how do you subtract, right? If this were like, I don't know, 14 minus 7, we could do that computation. But this is 4 root 7 minus 7. That's not a pretty computation. And if you try to write a decimal, Hawks is going to tell you, no, exact answers, please. So the best we can do is to just write it out like that and then put root x. If this were some nice number, like say 12 minus 7, then we can just be like, oh, okay, yeah, we can do that computation, get 5 root x. Not so pretty. So I just wanted to show you what would happen if you got, if you had to combine these coefficients and they weren't nice, pretty numbers. All right, just like in 9.2 and in the previous parts that we've done here, let's simplify each radical first because initially these are not like terms. Because we've got 12x, 75x, 108x. They're not like terms. So back in 9.2, we simplified these radicals, and this is also what we were doing, kind of like what we were doing before, where we can split these apart, you know, square root of 12 times square root of x. But I'm going a step further with this and saying, hey, remember how we said that 12, even though it's 12, square root of 12 is not a perfect square, we can split it up into 2 factors, 4 times 3. One of those factors is a perfect square. So remember how I had my little shortcut that I did where I said that you know, the square root of 12, I'm just going to kind of scribble it up here. The square root of 12 can be written as the square root of 4 times the square root of 3, and then the square root of 4 is 2. So it was that. I have my little shortcut where I just kind of split it apart and crossed it out and circled it if I took the square root to tell me that, hey, this is going to be on the outside of the radical and this is going to be under the radical. So the square root of 12 simplifies to be 2 root 3. The x stays under the radical. I'm just simplifying the numerical parts of the radical, okay? Square root of 75, I split that to 25 and 3. Why? Because I know 25 is a perfect square. So the square root of 75 is 5 root 3. Now if you need some help with these, remember this calculator simplifies square roots for you. See, 2 root 3, look, 2 root 3. Square root of 75, 5 root 3, 5 root 3. Square root of 108. So I'm just showing you all the behind the scenes details here of how these answers come about. So now look, root 3x, root 3x, root 3x. They're now like terms. So now I can combine them. So this stuff in pink are my coefficients. So if I take 2 plus 5 minus 6, I'm going to get 1. If you try to write 1 times root 3x, Hawks is going to tell you to simplify your answer. That's because this 1 is unnecessary, and you know Hawks does not like those unnecessary ones. So you can just write it as root 3x. That 1 is just understood to be there. So with these, you can use the calculator to help you simplify them, right? Because your calculator will do these square roots and simplify them into exact form pretty nicely. The cube roots, it doesn't do, but so we'll just have to do those by hand. Okay, so cube root 5x, cube root 40x, cube root 5x. Ooh, first thing I notice, these two are like terms. However, this one, let's not rule it out just yet as an unlike term. We can simplify this radicand further. So I split 40 into 8 and 5. Now, this is important to notice. If this were a square root, I would have split this into 4 and 10 because 4 is a perfect square. But because this is a cube root, I split it into 8 and 5 because 8 is a perfect cube. Remember the perfect cubes are 1, 8, 27, 64. So I'm trying to do this in my head real quick. So splitting those apart, that comes down. This splits up like that. This one comes down. The cube root of 8 is just 2. That sign right there comes down. Now in doing that, look, my radicand is the same all the way across. It's cube root 5x. So now I can just combine my coefficients because they're now like terms. Well, these two didn't have any coefficients written, so we know those are just understood ones, so I just wrote those in there just to help you. So we get 1 plus 1 minus 2, which is 0. So we have 0 times the cube root of 5x. That's just 0. So I chose this one because, you know, if you ran into this one, you might be like, what do I do? You know, because it's almost like, oh, everything's simplified too well. So you might be kind of suspicious of it. But yeah, if all your coefficients zero off, then that's just 0 times that, which is just 0. Okay, so that concludes 9.4a. So there'll be 2 other videos, one for 9.4b and 9.4c. So make sure you watch all 3 of these.